If you own a heat pump installed after 2020, there is a coil inside it corroding right now. You cannot see it. You cannot hear it. You will not know until the system stops heating, stops cooling, and a technician tells you the repair costs more than half what you paid for the machine. The heat pump your parents bought lasted 20 to 30 years. With a brazeable copper coil, a technician could fix in an afternoon. The heat pump you bought, the high-efficiency one the rebate program pushed, uses an all-aluminum microchannel coil borrowed from automotive radiators. Compact, efficient on a test bench, and when it leaks, the manufacturer's own service bulletin calls the field repair temporary. Coil replacement runs $600 to $2,000. Labor adds another $400 to $1,000. And the part is back-ordered for weeks while your house stays hot or cold. Today, we are exposing exactly what changed inside the coil, why the modern version is nearly impossible to repair, and the 3 heat pump strategies that survive, including one coil design a major brand still brags about by name. You just spent 5 figures electrifying your house. You bought the high-efficiency heat pump the rebate program pushed, the one with the government tax credit, the one the salesman said would pay for itself, and now a technician is standing in your driveway telling you the coil is leaking. The part is back-ordered for 3 weeks, and the repair quote is starting to look like a replacement. Modern heat pumps last 10 to 15 years. Coil replacement runs $600 to $2,000. Labor adds another $400 to $1,000. You bought efficiency. You got fragility with a warranty expiration date. Today, we're going to show you exactly what manufacturers changed inside the coil, why the modern version is nearly impossible to repair in the field, and the 3 heat pump strategies that can actually survive, including one coil design that one major brand is still willing to brag about by name. 30 years ago, residential HVAC durability came from overbuilt materials and repairable construction. The old systems were not magic. They were copper tube coils with aluminum fins, simple controls, forgiving refrigerant circuits, and equipment that did not chase every last test bench efficiency point. You could fix them. A technician could braze a leaking section and move on with his day. The design assumed the machine would need service over a 20 or 30-year life. It was built for that reality. Then the efficiency wars started. The Department of Energy tightened standards. January 1st, 2023 brought the SEER 2, HSPF 2, and EER 2 testing protocols, new metrics that changed how efficiency gets measured in raised pressure to extract more performance per pound of material and per ounce of refrigerant charge. Manufacturers did not respond by building better machines, they responded by building lighter, cheaper, harder to service ones. First, the coil architecture. Older heat pumps used conventional round copper tubes running through aluminum fin blocks. The tubes had enough wall thickness to handle decades of thermal cycling and enough diameter to tolerate a minor field repair. What changed? Manufacturers borrowed all aluminum microchannel technology from automotive radiators. Trane's own service literature describes microchannel as flat, multi-port aluminum tubes with extremely high surface area density packed into a compact slab. It transfers heat beautifully on a test bench. It also creates passages so tight and walls so thin that damage which once meant a localized braze job now means an OEM part replacement. ASHRAE conference literature notes that AA3102, the aluminum alloy used in extruded microchannels, has recognized atmospheric corrosion concerns in HVAC applications. The engineers know, the brochures do not mention it. Second, the copper that remains. Some systems still use copper tubes in the indoor evaporator coil, but those tubes got smaller too. Goodman specs 5mm copper tubes with enhanced aluminum fins on several current heat pump models. 5mm. That is not overbuilt margin. That is optimization math. Just enough material to hit the efficiency target, just thin enough to save manufacturing costs, and just fragile enough to develop pinholes when corrosion or contamination finds a weak spot over time. Third, the repair pathway. The old coil was a broadly serviceable component. A technician with a torch, some brazing rod, and 20 years of muscle memory could fix most leaks on site same day. The new microchannel coil is a module. Trane's service bulletin describes a temporary field repair kit involving epoxy, an aluminum wrapper, and a controlled heat cure for leaks in the flat tube area only. If the damage is anywhere else, you are ordering a replacement slab. That is not a repair culture. That is a parts cannon culture designed to move units. Fourth, the warranty math. Carrier says typical modern heat pumps last 10 to 15 years, with major repairs becoming more likely after about a decade. Most major brands offer 5-year base coverage or 10-year registered coverage on coils and compressors. You see the trap forming. The coil is engineered to hit the warranty window. It is not engineered to hit 30 years. When the leak shows up at year 11, you are outside the easy coverage period, staring at a repair bill that makes the salesman's replacement pitch sound almost reasonable. This is not an accident. This is a design choice. Compact efficiency and low refrigerant charge came first. Field serviceability came last. And you pay the difference every time something breaks. The failures start small and get expensive fast. Failure 1, the outdoor coil face. Microchannel packs dense heat transfer area into a compact surface, but those fins and passages are vulnerable to the real world. Dirt loading cottonwood seeds, lawn debris, a pressure washer held too close, a weed eater that throws a rock. Any of these can damage passages that were never designed to tolerate rough handling. The old chunky copper and aluminum coils could take abuse. The new ones punish neglect and punish accidents. Trane's own maintenance literature emphasizes specific cleaning procedures for microchannel because the standard shop vac and hose routine can bend fins and create more problems than it solves. This is where the trouble often begins. Performance drops. Efficiency falls. The compressor works harder to compensate. The meter spins faster. You do not notice until the electricity bill arrives, $40 higher than last summer. Failure 2, the refrigerant leak in your indoor coil. Your evaporator, often still copper tubed in many split systems, develops a pinhole. Could be formicary corrosion from volatile organic compounds in your household air. Could be manufacturing contamination left in the lines. Could be thermal cycling fatigue on a tube wall that was spec'd for efficiency numbers, not longevity. You notice because the system stops cooling or heating properly, ice forms on the refrigerant lines, or the compressor starts short cycling every few minutes. A technician arrives, confirms refrigerant loss, pressurizes the system, finds a leak, and quotes you the damage. Angie puts evaporator coil replacement at $600 to $2,000, with labor commonly running $400 to $1,000 on top. The refrigerant recharge alone is a licensed EPA-regulated procedure with its own bill attached. You are not fixing a leak. You are funding a small construction project inside your own house. Failure 3, the diagnosis trap. The technician finds the leak. Now the math turns ugly. Refrigerant handling is certified work. Section 608 of the Clean Air Act says so. The replacement coil has to match your system specs exactly. Wrong coil, wrong refrigerant circuit geometry, voided warranty, potential compressor damage. The repair parts are not sitting on a truck in your neighborhood. They are sitting in a regional warehouse maybe, if your model is still in active production and the distributor has stock. Angie cites condenser coil replacement averaging around $800 and full AC refrigerant leak repair averaging the same. These numbers assume the parts exist and the shop wants the job. Some independent technicians refuse to touch microchannel systems. Too much liability, too little margin, too many callbacks. You start hearing phrases like, you can fix it, but honestly, you probably shouldn't. Failure 4, the microchannel field repair reality. Suppose your outdoor unit uses a microchannel coil and it springs a leak in the flat tube area. Trane's service bulletin describes a temporary repair, epoxy application, aluminum wrapper, controlled heat cure at specific temperature limits, especially at copper to aluminum joint transitions, temporary. The manufacturer's own bulletin uses that word. This is not a 20-year fix. This is a hold it together until replacement fix. And if the leak is anywhere else on the slab, a header connection, a manifold point, a different tube section, you are not repairing. You are replacing. The part is proprietary. The lead time is whatever the distributor says it is. Your house stays hot in August or cold in January while you wait for logistics to catch up with your emergency. Failure 5, the hostage map. You bought a match system. High efficiency SEER 2 rating. Rebate qualified. The outdoor unit talks to the indoor unit, talks to the communicating thermostat. One coil fails. And now you are searching for the exact replacement slab, the exact refrigerant compatibility, the exact service pathway the manufacturer approves for warranty purposes. The system might still be under parts warranty, the labor is not covered, the refrigerant is not covered, the week without climate control while you wait for the part is not covered. And when the repair quote approaches half the cost of a new system, even consumer cost guides start pushing the replace versus repair conversation. You did not buy a repairable appliance. You bought a sealed module with an expiration date and a replacement funnel built into the ownership experience. Quick question before I show you what to buy instead. When your HVAC technician found a leak, did they actually repair the coil on site, or did they go straight to you need a new one? Drop a comment. I am betting most of you never saw a blazing torch come out of the truck. Here is what to buy instead. Number 3, the budget play. A simple Goodman split heat pump with a conventional copper tube, aluminum thin coil. Look at a model line like the GSZB4 or GLZS5B class equipment. Goodman specs copper tubes with enhanced aluminum fins, the coil architecture your grandfather's contractor would recognize immediately. No exotic microchannel geometry requiring specialized repair kits. No proprietary slab replacements with 3-week lead times. Single stage or simple 2-stage operation with straightforward controls. Accessible service valves positioned where a technician expects them. Mainstream parts availability because half the HVAC supply houses and service trucks in America already carry Goodman compatible components on the shelf. Trade-off: this is not the glamorous choice. It is often noisier than premium variable speed units, fewer smart home features, no touchscreen thermostat bragging rights at the neighborhood cookout, but that is exactly the point. You are buying a common architecture with a common repair pathway, serviced by common technicians. If you avoid one proprietary coil nightmare over 15 years, the basic machine wins the lifetime cost math decisively. Expect to pay less upfront and spend dramatically less on the service call that does not turn into a forced replacement. Number 2, the corrosion-conscious mainstream option, Mitsubishi M-Series ductless heat pumps, specifically the MUZ-JP class for single-zone applications. For a smaller home, a garage conversion, a single-zone addition, or a strategic room-by-room electrification approach, Mitsubishi gives you a clear material story right in the spec sheet. The company states that the outdoor heat exchanger fins receive a bluefin anti-corrosion coating designed for added protection and longer service life in real-world atmospheric conditions. This is not a promise of immortality. No coating lasts forever, but it is a signal that the manufacturer is at least acknowledging the coil environment durability reality up front, instead of hoping you never search aluminum corrosion HVAC problems until after the warranty expires. Trade-off: ductless is a different installation model than traditional ducted systems. Line set routing and quality matters significantly. Whole home conditioning may require multiple indoor heads or a different multi-zone product family with higher complexity. But for targeted applications where you want proven corrosion resistance from a manufacturer willing to talk about it, Mitsubishi's coating story is worth the dealer conversation. Number 1, Trane or American Standard models with spine fin outdoor coils. This is the recommendation that answers the entire episode. You watch me tear apart the microchannel repair problem for 10 minutes. Here is a major manufacturer who went a different direction with their coil design and is willing to name it publicly as a selling point. Trane and American Standard market their spine fin coil design as an all-aluminum alternative to conventional copper aluminum construction, but critically, it is not flat-port microchannel. Spine fin uses continuous aluminum tubing with bonded spine-shaped fins wrapped around the tube rather than the dense multi-port channel geometry that creates the repair nightmare. The design resists corrosion differently. The marketing materials brag about durability and longevity instead of hiding the coil construction behind efficiency jargon and rebate qualifications. And Trane's current product literature shows many residential heat pump models carrying a 10-year registered limited warranty on the outdoor coil and internal functional parts, the kind of coverage that signals the manufacturer actually expects the equipment to last. You get competitive efficiency ratings, you get a coil architecture the company treats as a genuine selling point rather than a liability to downplay. Trade-offs exist. Dealer quality matters enormously because Trane sells through a contractor network, and installation competence varies by shop. Pricing runs meaningfully higher than budget brands. Not every unit in every product line uses the identical coil configuration, so you must confirm the specific model, but this is the most on-theme recommendation because it gives you concrete design language to look for and ask about. You are not just buying a brand name, you're buying a coil philosophy backed by a warranty. Walk into the dealer and ask them to show you the spine fin and explain why it matters. If they cannot do that clearly, find a dealer who can. Check the coil, check the warranty, check the coil, check the warranty. If the salesman cannot name the coil architecture on the unit he is quoting and the parts coverage drops to 5 years unless you mail in a registration card, You are not buying a heat pump. You are renting one with a purchase price attached. Stop buying the efficiency brochure, buy the Coil. Subscribe, because next I am covering inverter control boards, the other half of the modern HVAC trap. The coil leaks first, or the electronics fail first. In either way, you land in the same nightmare: dealer-only diagnostic software, proprietary circuit boards, and a homeowner push toward replacement instead of repair. That one might be even worse.